The Zen of Python is a set of guiding principles that shape the language's philosophy. These 19 guiding principles are a mindset that encourages writing clean, readable, and efficient code. Today, we'll go through a few of the more important ones and look at how these guidelines could be applied to make your code more Pythonic. Beautiful is better than ugly is not just about aesthetics. The code that we write will be read by our future selves and other developers, so it's important to take time and make the code easy on the eyes. Let's take a look at two examples of calculating an average to see this principle in action. At a glance, it's easy to tell which example is beautiful and which is ugly. The beautiful version is using a self-descriptive function named parameter. We can tell at a glance that the function is calculating an average of numbers. The ugly version has improper spacing around variable definitions, making it difficult to read, while the beautiful version properly spaces variable definitions. Using built-in functions abstracts away common logic and makes the code more readable. The beautiful version uses the sum and len built-in functions, while the ugly version makes the function complicated by writing its own logic for summing a list. The beautiful version identifies potential edge cases and handles them, while the ugly version could throw an exception. This principle is all about writing elegant code that optimizes for maintainability. It's not just about making it work, it's about making it easy to understand and modify in the future. Explicit is better than implicit encourages us to write code that clearly states its intentions, making it easier to understand and maintain. It's preferable to write more code if it makes it easier to understand at a glance. When writing functions, use type-ins for parameters and their return value. These make it immediately clear what kinds of data the function expects and what it will return. Only use ternary operators if they make the code easier to read and reason about. In the top example, the use of the ternary operator makes the code harder to read, compared with the bottom example, where we split the conditional logic into its own branches. By making these changes, we create code that more clearly states its intentions. This explicitness helps other developers and your future self understand the code quicker, and reduces the likelihood of errors. Being explicit might require more typing, but it pays off in the long run through improved readability and maintainability. Simple is better than complex encourages us to write code that's straightforward and easy to understand, avoiding unnecessary complexity. Let's take a look at two implementations of a function that gets the squares of even numbers from a list. The top function is more verbose and uses a for loop with an if statement to explicitly build a list. The function is explicit, but it's a bit wordy. The simpler function uses a list comprehension. This version is not only shorter, but it's arguably easier to read and equally as explicit once you're familiar with list comprehension syntax. By favoring straightforward solutions over complicated ones, we make our code easier to understand, maintain, and debug. In Python, we aim for simplicity and clarity. This principle doesn't mean we should oversimplify complex problems, but rather that we should strive for the simplest solution that solves the problem at hand. Readability Counts emphasizes that code should be written first for humans, then for computers. Let's compare two identical functions that sum positive numbers. The top example is concise but confusing. It's not immediately clear what this function does. This function is easier for computers to understand, but not for humans. The bottom example is more verbose, but it's more readable for humans. The function name and parameter of the top function are short and non-descriptive, making the purpose of the function obscure, while the bottom function clearly indicates what the function does and what kind of input it expects. A brief description of the function's purpose is included in a docstring, which is helpful for any human reading or using the code. We want our code to be easy for humans to read, not just for computers to execute. Clear naming, proper documentation, and self-explanatory code all contributes to readability. It might take more time to write initially, but it saves more time in the long run when you or others need to work with the code again. A critical skill in Python is properly handling errors. This guideline emphasizes the importance of proper error handling and reporting in our code. The top function uses a generic except, which will catch any error that might occur within the function. The bottom function uses specific exception handling. It only catches the zero division error, not all possible exceptions. The top function silently ignores any errors that occur, which hides potential problems and makes debugging difficult. The bottom function prints a clear, informative message and re-raises the exception to ensure that the error is not silently ignored, but propagated up the call stack. By doing this, we know exactly what went wrong and where it went wrong. We want to catch and handle exceptions, not ignore or hide them. Proper error handling makes our code more reliable and easier to maintain. It might seem like extra work, but it saves a lot of time and frustration in the long run when debugging and maintaining code. One obvious way to do something encourages us to use the currently accepted best practice for common tasks. It doesn't mean that there's only one way to do things, but rather there should be an obvious solution that experienced developers naturally gravitate towards. Python has evolved over time, and so have its string formatting methods. The percent operator and format methods still work, but they're considered outdated and less readable, especially for complex strings. The more modern preferred way is to use f-strings. It's now the solution that Python developers use because of its readability and conciseness. When there's a standard, obvious way to do something, it's usually best to stick with it. This consistency makes Python code more accessible and easier for all developers to understand and work with. Avoid hard-to-explain code emphasizes that code should be easy to explain to other developers. The bottom function is clearly more readable and easier to explain to another developer, even though it's doing the exact same thing as the top function. While the top function works, it's densely packed and might be challenging to explain, especially to a less experienced developer. It uses nested functions and a lambda, which can be confusing at first glance. The bottom function clearly separates the logic and uses descriptive variable names. If the code is hard to explain, it might be worth reconsidering the approach. Always consider how you would explain your code to another developer. If you enjoyed this video and learned something, consider following me on the following platforms for more content.